Hello everyone. Today we are going to discuss the fourth problem of Leetcode Biweekly Contest 120, which is find number of coins to place in tree nodes. So what is the problem? The problem is that we are given an undirected tree with n nodes level from 0 to n minus 1, which is rooted at 0. Now we are also given some edges of the tree that is given to us, and another thing is that we are given an cost array where cost array defines the cost assigned to the ith node, right? Now we have to put some coins in the particular in each node of the tree. So there are two conditions given to us. If size of the subtree of node I is less than 3, we have to place one coin. If the size of the tree is greater than equals to 3, then we have to take the maximum product of cost values assigned to the three child nodes of the tree of the current node, right? And if the product is negative, we have to place 0 coins. So let's take this first example. So the first example is nothing but an easy graph: 0 1 2 3 4 and 5. And what are the cost values assigned to this? The first zeroth node has a cost value assigned as 1. This node has 2, this node has 3, this node has 4, this node has 5, and this node has 6. Now we will try to find what is the number of coins we will place in each node. Now this 1 1 2 3 4 5, these 5 nodes only uh, have no child of them, so the subtree size of these 5 nodes is 0. So we have to place only one coin, right? So we are placing 1 1 1 1 each. Now for the zeroth node, the subtree size is 5, so we have to take maximum product of cost values of the any three nodes in the subtree. So we will take the cost value of 5 4 and 3, so 6 into 5 into 4. So the cost value of the zeroth node, sorry, the number of coins you have to place on zeroth node is 120. So here you can say the answer is 120 1 1 1 1 1, right? Now let's take the negative case also. Now let's say instead of positive values, let's say they are negative values: minus 2 minus 3 minus 4 minus 5 minus 6. So the maximum possible product of this will be like something minus 2 into minus 3 into minus 4, which is negative. So we have to place 0 coins then on the zeroth node, right? So I hope you got the explanation of the sample. Now let's jump into some observation. So one important thing to observe in the constant is that the cost value could be negative. That's what I have explained here, the zero case, right? Now let's jump into some observations. The first observation you can make is that if you have all the cost values of the for a current node, all the cost values of its children, then what we can do? So if we have all the cost values of the child nodes given to us, let's say let us define in two sets. One is positive cost values, one is positive cost values. Let me write it in text format. So let's say we have all the cost values of a subtree of the current node. Let's define them in two sets. One is positive cost values and another one is negative cost values, right? Then what could be the value of the maximum product of these triplets from this positive cost and negative cost? That could be, right, positive cost 0. Let's say positive cost and negative cost both are sorted in descending order. Then one possible value will be positive cost 0, positive cost 1 into positive cost 2, right? That is one value, one possible value of the maximum product. And another product would be negative cost 0 into negative cost 1 into positive cost 0, right? I hope you are getting that, right? Because negative into negative will give us positive value, and this is already positive. So there are three possible values: positive cos 0 1 into 2, and negative cos 0 into negative cos 1 into positive cos 0, and another one could be 0. So you have to take maximum of these three values. So there could be some cases where positive cos size would be less than 3, or negative cos 0 negative cos size will be less than 2. In that case we have to handle the above two cases, right? We have to do some if conditions here, and we have to handle these cases, right? Now we have defined this. now let's jump into some more observation. So one observation I can make is that this problem, positive cost and negative cost thing, we can do it in some depth first traversal, right? Because we will be only needing the children cost arrays, children positive cost arrays and children negative cost arrays, and then we can build our the current nodes positive cost and negative cost values, right? So let's say we have some positive cost of children and negative cost of children, then we will insert all the values in the parents positive cost or negative cost, right? Now that is the first observation. We can do it using some simple depth first search. Now the second observation, let's say this is the first observation, this is the second observation, the DFS one, DFS is sufficient. And the third observation is important, is that we are only taking the top three values of positive cost, and we are only taking top two values of the negative cost. So we can trim the positive cost and negative cost sets. In the maximum value of positive cost size will be 3, and length of the negative cost size will be 2. So we don't have to take all the cost. Instead of that, we can take 3 maximum positive costs and 2 maximum negative costs. So I hope the explanation of the problem statement and the my solution approach is clear to you. Now I will jump into the code and I will show you how I handle this positive cost and negative cost values. So let's jump into the code, right? So I have taken three functions. These three functions are important. One function is that we have the current parent set, and this is the child set. How we are adding the parent set child set values in the parent set, and this add function is used to insert one element to a set. If we are inserting that element in the set, if the size of the set is greater than 3, we are erasing the minimum value from the set. So this is quite trivial. So this part is quite trivial, how we are inserting each element from the child set into the parent set. The size of the child set will be maximum 3, and the child of the parent set will be also maximum 3, and after the insertion also the size of the parent set will be maximum 3, because we are erasing the minimum element from the set if the size is greater than 3, right? So these two functions I have already explained what we are doing here. Just this operation, we are just taking positive and negative values from 3 and 2. Here I have used 3 here because I don't want to uh, define two different functions for positive and negative sets. I have defined one single function for positive and negative sets, so I have taken this also 3. Okay, I hope you got it. Now how we are calculating this, I am storing the positive and negative in a array of sets, array of multi-sets, you can say. Set will not help us because there could be similar values, so we are taking multi-sets, and we are defining one array of multi-sets, right? Two values will be there, one value will be for positive. Here I have taken max min. Instead of that, you can name it as positive negative. So positive will be the first element from the array, and negative will be the second element from the array. Now if the positive size plus negative size is less than 3, that means that there will be the subtree size. The subtree size will be the positive element size and plus negative element size. If it is less than 3, then we are just placing one coin here, there, right? If it is if it is greater than equals to 3, then we will do the further processing. So instead of iterating over sets, I have taken some positive list and negative list as the vectors, because I want to do this indexing operations like random access. So this is, if the positive list size is equals to 3, we are taking this as maximum value that I have already explained here. This operation positive equals 0, 1 into 2. Now and if the negative list size is greater than 2, then we are doing negative list 2 into negative list 1 into positive list back. So these two operations are quite some kind of, what you can say, they are not needed. Only one operation will be needed if you sort it in descending order. Because I am sorting it in ascending order, I have to take care that the negative list size could be 2 also. So you can sort it in as descending order and remove one of this operation that will not be needed, right? Now this is the DFS. I am doing the DFS for the child node and modifying the this is for the positive cost set, and this is for the negative cost set. Now if cost I is greater than 0, of the current elements cost is greater than 0, I am putting it into the positive set. and if it is less than 0, I am putting it into the negative set. And at the end, after putting it into the set, I am calculating the current coin value. Calculator will define the number of coins I have to put in into the current node, right? So the rest of the part is quite trivial. I am building the adjacency list, and also I am clearing the array also, right? Here I am just initializing. This part is for initialization, and we are doing DFS for the from the zeroth node, and we are just marking the answer in the DFS part itself. So at the end we are returning the answer. I hope you understood my solution and explanation. If you have any doubt in any part of the video, you can always write in the comment section. I will try to reply each and every comment. I will also provide the link of my code in the description box. You can have a look at it. If you find this video helpful, please like the video and subscribe to my channel. Thank you.